Okay, ladies and gentlemen, this is the Unit 6 notes going over our Unit 6 review packet. One of the things I want to remind you about residual plots. These four plots are residuals. What we are doing with these residuals are we're trying to figure out, is this line a good fit or is it not a good fit? And what I told you way back when we did Unit 6 was that if it made a pattern that look like a U-shaped pattern, those are not good fits. Not a good fit because it looks like almost like a parabola. This is not a good fit. It looks like a parabola. What we want to know if it's a line of best fit is it really kind of close? Are they all sort of spread out randomly kind of in the middle of this horizontal line? If it is randomly above and below, then that line of best fit is probably pretty good. Yes. Yes for B and for, I believe this is a D. I'm not sure if your guys' has a typo or not on it, but I'm going to circle that so I can go back and look at it. It's no on the A and the C. Some people got confused by this bottom question. As I went around, I remember one of my students, as I was stamping homework, said, I got totally lost on this kind of question. So let me explain. You had the numbers 42, 44, 44, and all these numbers right here. What you were supposed to do is between 40 and 45, how many numbers do you have? You have 3 of them. You shade in that you have 3 numbers from 40 to 45. You have one number that's between 45 and 50. That's the number 47. And you can make a bar graph or a histogram that has this information in the picture right there. And then you have to be able to answer some questions about this. Like, what's the minimum value? What's the smallest value when they're in order? The minimum is 42. What's the maximum? What's the biggest number? It doesn't matter that there are 3 83s. The largest number is an 83. What's the range? If you forgot how to find the range, it's the biggest number subtracted by the smallest number. 83 minus 42 is 41. I wrote my work right there if you needed to see it. And then what is the median? The median is the exact middle of the data. Easiest way to find the median is to count. I counted over. Let's see. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers this way. And I go 1, 2, 3, 4, 5, 6, 7, 8. Did I mess up? I miscounted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the numbers that I have, 10 numbers this way is 63. 10 numbers this way is 61. So the median is exactly in the middle. It's the middle number. And if there's 61 on this side and 63 there, and the median's the middle number, I have to find the number that's in between 61 and 63, which is why my median is 62. And then the first quartile, if you cover up the median, you find the median of the median. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I need the number in between 52 and 56. Comes out to 54. It's the average of those two numbers. If I want the third quartile, cover up the median. You want the median of the right side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You can see I put a Q3 in between the 66 and 66, which is an average of 66. What's the percent of numbers in the interquartile? Interquartile, IQR, is interquartile range, is from Q3 to Q1. This is 50% of your data. What we talked about a long time ago, from the box to the whisker is 25% of your data. This other box and whisker is 25% of your data. And then this to the median is 25%, 25% of your data. So don't forget, interquartile range from here to here is 50% of your data. That's what it is. I'm going to put a little percent right there. Like that. Turn to the page. There weren't too many people who had issues with number 17. It was true, false, and I wrote that on C, less than 20 people spent less than $100. True, false, can't be determined. It cannot be determined. You cannot figure out that less than 20 people spent less than $100. It's impossible to tell. Because you know for sure that 10 people spent 26 to 75, but you don't know how many of these people, 25 of them, spent between 76 and 125. You don't know if they spent $100 or less than that or more than that. It's too hard. You can't determine it based off of this picture. Scatterplots. If we talked about positive correlations, negative correlations, or no correlations, a correlation is there a relationship? The easiest way to describe a positive correlation is, do the numbers sort of form a line? And on number 18, yes, they look like they form a line. Is it going up or is it going down? This line is going upward. That's why it's a positive correlation. Now, you can measure a correlation by a number, and that number is either going to be somewhere between positive 1 and negative 1. The closer these dots, the closer these points are to a line, then the closer to the value of 1 it's going to be, if it's positive. If they're close to a line that's going downward, it would be close to negative 1. So we want to pick a value that's going to be really close. Do these look like they almost form a line? I think they do. I think they're really close to a straight line. So I'm not going to use a negative correlation. I'm not going to use 0. 0 means that they're really, really random. This means that there's almost a straight line going downward. This is like really random going downward. This is going upward, but not very close. I would pick this value, 0.9, as my, that's how close of a line. Think of it as 90% of a line. Using the coordinates of 4 and 40 and 8 and 50, find the equation of the trend line, plot the line. What I did with those two numbers is I found the slope, y2 minus y1, over x2 minus x1. So I did 50 minus 40 over 8 minus 4, which came out to 10 over 6, which was 5 over 3, divided by 2, divided by 2. And then you can figure out what the y-intercept is by where it crosses the line, and we're supposed to plot it. So there we go. Then number 19, we got to hit some of these words again, some of these things that we taught you that you need to know. Some of these numbers are fractions, some of them are not fractions. The word frequency. Frequency. When you see the word frequency, it means how many. What is the marginal frequency? How many students in the margins who chose TV? So we look and we see TV. How many total students chose TV? I see 88. Marginal frequency means how many in the margins. Do not divide it unless it has the keyword of condition, relative. That's the word I was thinking of. When it says the word relative, marginal relative frequency, it means we want to know how many in the margins compared to the total. If you see the word relative, I taught you back in Unit 6, I said it is similar to what your relatives like to do. They like to compare you to your cousins or to your nieces or to your nephews. And so, thank you. And so you'll see some of these have whole numbers, some of these have fractions. The ones that have fractions all say the word relative in them. Relative. The only one that you do not compare to the grand total when it says relative is when it says conditional relative. Conditional relative means instead of dividing by the grand total, you're going to divide by the given condition. Given that they prefer to watch the game. So that's what you're going to put on the bottom of your fraction. Going over to the other graphs up at the top. When I see these particular graphs, there are different ways to describe histograms. Uniform, skewed, symmetric. If you forgot what those words means, uniform means almost straight across. They almost are all at the same level. I hardly ever have a graph that's uniform when I'm showing you your grades. Most of my graphs are skewed. I have a lot of students who get more A's and B's than anything else. Sometimes we have some D's and F's that are skewed. When I used to teach at Gateway, because I used to, we used to have a curve like this where A's are on this side, F's are on this side. In my Gateway days, F's were on this side, A's were on this side. That's how the graphs look when I actually did teach. They were skewed, but the wrong direction. Okay. Now that I teach at Buchanan, a lot more of my graphs are skewed to the right. I have more A's and B's and C's than I do D's and F's. Thank you. I appreciate it. Okay. Lastly, 21 and 22. We talked about linear regression, and if there is a line, this is the line of best fit. If we asked you to make a prediction based off of this, you can just plug the 7 right into it, figure out what the value is. You can plug the 15 right into where the x is, and you can get a value, and then it says round. That's what I did on 21, and so on. So I'm just going to let you look over those answers. We got it. That's the end of our Unit 6.